welcome back. And at the end of the last segment we asked you to go away and evaluate the strain in our 30mm diameter bar with an original length of 130mm if the observed extension was 2.5 micrometers. Well, we evaluate the formula above, or we use the formula triangle such that we know that epsilon, the symbol for strain, is equal to x divided by the original length. We're working in millimeters. We say this is 2.5 times 10 to the minus 3 divided by 130 millimeters. We can then convert into micros times 10 to the minus 6 by moving our decimal place 3 places on the bottom. And we have 2.5 over 0.13, which ends up as, in the calculator, 19.2 times 10 to the minus 6, which is 19.2 micrometers per meter, and therefore 19.2 microstrains. Okay, so we can move on to the next principle now, which is stress distributions. So far we've examined only components with a single stress, in fact only a particular component, a bar really, different cross section, but nevertheless the same conceptual component. The stress values realistically in components have a number of stresses throughout, such as the component shown here. The component here, we've plotted the stresses using the CATIA finite element software, and we can see that blue is low stress while we have high stresses in red and yellow regions. So we have what's known, we say that the component has a stress distribution, or a distribution of stress throughout it. It's also obvious that the component stress varies from point to point within the component. So it varies with position, and we refer to a stress that varies with position as a stress field. So you're now in a position, now that we know what the definition of a stress field or a stress distribution is, to evaluate the stress distribution in the part shown. The clues which can be given are from the last slide really, is this particular component comprises of two different cross sections, one of 20mm diameter and the other of 10mm in diameter. It is these that need to be used in the stress calculation, force divided by area. So if you could try and calculate that out and come back, we'll give you the solution in the next segment.